Hello everybody, welcome back. This video is about the quadratic formula, but also the discriminant. Let's start off with this problem though. Jenny's solving an equation 4x squared equals 13x minus 3 with the quadratic formula. Which values could she use for a, b, and c? Well, first let's make sure we understand standard form. ax squared plus bx plus c equals 0. Basically, everything is to one side of an equation and you're setting it equal to 0. In this problem, we have 4x squared equals 13x minus 3. First thing we need to do is subtract 13x from both sides. But also add 3. You can do that 2 steps at once. Notice none of the terms will actually add together on the left side of the equation. We're now equal to 0 on the right side, but we just write 4x squared minus 13x plus 3. Those terms cannot add or subtract together. They're not like terms. However, we can identify our a, b, and c now. Here's the a number. A is 4. Here's the b number. B is a negative 13. And here's the c number, positive 3. You can use those numbers to figure out the quadratic formula, use it in the quadratic formula or the discriminant if needed. Well, let's talk about the discriminant. Of course, we have our standard form here. Let's write that again. ax squared plus bx plus c equals 0. The discriminant discriminates the different types of answers. This is the formula for the discriminant, and we'll learn later that it is part of the quadratic formula. b squared minus 4 times a times c. Alright, and that equals the discriminant. We'll use a capital D. Alright, and there's 3 scenarios. D could be greater than 0, positive numbers. D could be equal to 0. D could be less than 0 for negative numbers. If it's greater than 0, we have 2 real solutions. I'll just abbreviate solutions. If D is equal to 0, there is 1 real solution. And if D is less than 0, there are 0 real solutions. But there would be 2 imaginary or non-real. This video isn't going to get into the imaginary part, but they do exist in an imaginary number plane. Let's go back and classify a little bit further. If you do have D equals 0, you're going to have 1 real solution, and it is going to be a rational solution. If you have 2 real solutions, if the discriminant is a perfect square, the discriminant is perfect square, then the 2 answers are going to be rational. But if the discriminant is not a perfect square, it will be in irrational solutions. Alright, let's try it out. So we have, what's the discriminant D of the equation? Alright, our A number is 3, our B number is 15, and the C number is 10. Remember the discriminant D, b squared minus 4 times a times c. 15 would be b, 15 squared minus 4 times the a number times the c number. The a number is 3. The c number is 10. 15 squared, 225. 4 times 3 times 10, 120. 225 minus 120, 105. Alright, so that's the discriminant. And we could tell something about the solutions to the quadratic. 2 real solutions for sure. Since this number is not a perfect square, the answer would be irrational. They would have 2 irrational solutions. Let's look at another one here. Now notice it's not perfect square, or it's not in standard form. We'd have to subtract 16x from both sides and then add 32 to both sides. (2x squared minus 16x plus 32 equals 0. Our A number is 2, our B number is negative 16, and our C number is 32. The discriminant D would be B squared minus 4AC. In this case, negative 16 squared. Notice I put it in parentheses to show that the negative is also getting squared, minus 4 times A times C. The A number is 2, the C number is 32. All right, 16 squared, 256. 4 times 2 times 32, also 256. That gives us a discriminant of 0. Means there is only one solution, one rational solution. Alright, that brings us to the quadratic formula. The quadratic formula can be used to solve any quadratic equation. You just need to know what the A, B, and C are. It goes negative b plus or minus the square root of the discriminant, which we learned was b squared minus 4 times A times C. All that's the numerator, and the denominator is simply 2A. Notice we have the plus minus, and that would allow for positive or negative answers. A couple examples showing how it works. X squared plus 8x plus 6. Alright, our A is 1, the B is 8, and the C is 6. We can use that to solve our quadratic formula. Negative b would be negative 8, plus or minus square root 8 squared minus 4 times A times C. The A is 1 and the C is 6. 2 times A, 2 times 1. And now it's a matter of just simplifying what we see here. Negative 8 plus or minus square root 8 squared is 64. 4 times 1 times 6, 24, all over 2. 64 minus 24 is the next simplification. Square root of 40, all over 2. Now, 40 is not a perfect square, but it does break down. We want one of the factors to be a perfect square, and we can do that if we break it down into 4 times 10. We can take the square root of 4, but not the square root of 10. So now we have negative 8 plus or minus 2 square root 10 all over 2. And that simplifies to negative 4 plus or minus square root of 10. And we can figure out those exact decimal answers if you wanted to by plugging it in the calculator. But our two answers, negative 4 plus square root of 10, negative 4 minus square root of 10. Let's do one more, and we're going to find the decimal approximation to the two irrational answers. In this problem, the A is 1, B is 9, C is 10. X equals negative b, negative 9, plus or minus b squared, 9 squared, I'll show that to be 81, minus 4 times the A times the C, the A number 1, the C number is 10, all over 2 times A, which is just 2. Simplifying further, negative 9 plus or minus square root 4 times 1 times 10 is 40. 81 minus 40 is 41. So here's the non-decimal answer. -9 plus or minus the square root of 41 all over 2. And you can use a calculator to figure that. It's a good idea to put the numerator in parentheses when you're using a calculator. And they're dividing by 2. So one answer is going to become -1.298, and it goes on to have more decimals. But we're going to round it to the nearest tenth, as they say in the problem here. -1.3. And then calculator, you just go back up and change your plus to a minus, and you get -7.7. Two answers, -1.3, -7.7. That's how the quadratic formula works, as well as the discriminant. Thank you for watching.